In this video, I want to talk about the properties of electricity. You know, what electricity is in its most sort of fundamental form, right? So electricity is very fast. You can see here it's like 670 million miles per hour. It approaches the speed of light. It is incredibly fast. It's one of the things, it's one of the faster things that we even can measure, right? So very, very fast, right? And what electricity is in its most basic form is just a difference in potential, right? Electricity is all about potential power, potential work, right? It's to think about potential, it's like the ball at the top of a hill. It's just sitting there. But boy, as soon as you give it a little push, it's ready to roll down a hill, right? It has energy. Another analogy that we often use for electricity is a water tower, right? Is to think about water. Water in a water tower just sitting there, it has the potential to flow down if we let it. Right? So if we think about the water tower as a battery that has energy saved in it, and we think about the pipe as the wire that allows that energy to flow, and then the water wheel at the bottom is work, right? So in an electrical system, we have a battery, right? We have wires that connect our circuit or our system, and then we have a load, which is our light bulb, which is work. Now, how does electricity flow? That's what what we want to talk about is what this flow is through this electrical circuit, right? And so to understand the flow of electricity, we have to sort of understand a little bit about atoms and about the atomic at the atomic level, right? So an atom is made up of three parts, right? So there are neutrons, and neutrons are neutral, right? They have a neutral charge, they occupy space, and they help balance a system, right? Protons, which are in the center, right, or in the nucleus, right, they have a positive charge, and they're stuck to all the neutrons, and they form this little glob in the middle, which is the nucleus, right? Circling around, right, in orbits around the nucleus, electrons swing. Now, I don't know if you ever remember playing with magnets in elementary school. How about the north and the south poles of a magnet attract one another, and a north repel one another? Well, the same thing is true of negative and positively charged particles. They are attracted to one another. And in order for these electrons to stay swinging in their orbits, they are attracted to one another, but by swinging around, right, centripetal force, they're able to maintain these orbits, right? So an electron orbit. The number of protons is going to equal the number of electrons, right? So if we have the most simple atom, which is the hydrogen atom, has just one proton and one electron, right? So they're attracted and by swinging around, so we have one in an orbit. As we move to our next one, the helium has two protons and two electrons. The number of protons and electrons determines what the element is, right? And we have, specific elements like oxygen, right? And oxygen has 8. I think there's 8 there. And then that occupies 2 shells, right? The first shell can only hold 2. The next shell can only hold, I think it actually can hold 8. Oxygen only has 6, right? In its outer shell for a total of 8. And then let's look at aluminum. Aluminum moves up to its 3rd shell, right? So each shell can only hold so many electrons. And the electrons in the outermost shell are known as valence electrons, right? So if we look at this, we have our nucleus, right? We have our first shell with 2. We have our second shell that holds 8. Our third shell can hold 18 electrons. Our fourth shell can hold 32 electrons. And electricity actually flows through the valence electrons. It's the electrons of any element that are in the outermost shell that create the flow of electricity, right? So it's these valence electrons. If you think about the idea that we have electrons in our outermost shell, maybe we only have 1 or 2 valence electrons, right? They're barely hanging on, right? There's not a lot of attraction to hold them to that nucleus because there's only 1 of them or 2 of them that are flowing around, right? And so if we introduce a new electron into the orbit of an atom, right, it's not happy with that and it wants that electron to move on. So it pushes it to the next atom, which then pushes it to the next atom. And so you can see down here in this little GIF that as we introduce a new electron, it's pushed along from atom to atom. And that's the basics of electron flow and of the flow of electricity.